Hey, welcome to 7-7. We're working on comparing linear increase and exponential growth. The takeaway from this is that in the long run, exponential growth will always overtake linear or constant increase. So let's take a look at how this works. That's the best way to get the idea. There's a guided example on 439. Let's go ahead and we'll take a look at it. And it says, suppose you have $10 for 2 weeks. Your rich uncle agrees to do one of the following. Option 1, increase what you had the previous day by $50. Option 2, increase what you had the previous day by 50%. Which option will give you more money? Well, making a table is one way to solve this problem. And we can compare the two options for the first week. Now, we can use the now-next method to fill in the table to get the exponential growth factors. For the $10 plus 50, that's pretty easy. We start with 10, we add 50, we get 60. We add 50, we're at 110. We add 50, we're at 160, 210, 360, and so on. So pretty easy to do. A little bit more awkward when we're dealing with the multiplication of the $10 times $1.50. So let's take a look real quick at the calculation in the calculator. We're starting out with $10. We enter that. Now we're going to multiply that times 1.5. 1 is the original amount, 0.5 is the 50%. So 1.5, and I hit enter, and I get, not surprisingly, I get $15 after the first day. Half of 10 is 5. 5 and 10 is 15. Well, the next day, maybe to you it's obvious, to me less so. That's $22.50, because it's $7.50 is half of 15, right? And it gets a little squirrelier as we go along, so we can just keep hitting enter, and we find ourselves getting more and more value, higher and higher values there. Well, what is it at the end of a week? So let's see, we had 1, 2, 3, 4, 5, 6, 7. So it's $170 after the end of a week, and you can figure out what it is for the constant option at the end of 1 week. And I think you're going to find that at the end of a week, the $50 a day is a much better deal. You get some good money with that. Now, if we can carry that on and we look out beyond that and we go to the full 2 weeks, then what option is going to be, what's going to be the better option? Well, let's take a look here at what might be. I've got a table I put in here. Here we go. And we'll move that down a little bit. So this is week 3, 4, 5, 6 out to 14. 10 plus 50 is the constant increase. And at 7 days, we get $360 for the 7 days and $170.86 for the percentage increase. So if it was only 1 week, the $50 is a lot better deal. But it's 2 weeks long. At the end of 2 weeks, we'll see that for 14 days, the constant increase, we're at $710, not shabby. For the percentage increase at the end of 14 days, we're at $2,919.29. There is no doubt which one is the better option. Takes us back to that big idea here that in the long run, exponential growth always overtakes the linear increase. So to answer the question for this particular problem, the table shows that starting on day, which day was that? Looks like around day 10, option 2 begins to give us more money. And in the long run, option 2, increasing by 50% each day, is the better choice. So you should be comfortable with the next now calculation, being able to run out a quick series like that to compare something. Let's take a look at the same problem and look at it graphically. And to do that in a graph, to do this calculation in a graph with our calculator, okay, we're going to be doing our comparing using a graph. We can do that in the calculator pretty quickly. We open up our calculator. We're on the home screen. Click graph. I get my calculation screen. I've already put in one of the functions. F sub 1 of x is equal to 10 plus 50 times x. I want to put in the other one, the other function, and this will be the exponential increase function. And that'll be 10 times the exponential increase, so that was 1.5, and that's raised to the x power. So that's our increase, and we'll go ahead and hit enter. And I can see clearly where they cross. No, not really. I need to do something here to allow me to get a better view of this. And so we're going to go ahead and bring this down a little bit. And I need to change my scales, so Window settings. I want to see the axes, so I'm going to put in a -1 for x minimum. For x max, I'm going to put in 14 because that's how many days. Y min, again, I want to see the x axes, so I'm going to put in a -1. And Y max, we know that it went up pretty high from the results we got earlier, so I'm going to make this 1500. And now I got a graph that makes some sense. From this graph, I can use my intersection command under Analyze Graph Intersection and set the boundaries for it, find out what the intersection value is. Or I could look at the graph and try to approximate where that value is. But from it, I could pull out the information. And clearly I can see from this graph that the exponential case is going to produce far better results over time than the linear case, although the linear fit was much better in the shorter term. So that's graphing it using a calculator. Let's look at the same situation, and we will be doing activity 1, which involves a spreadsheet. I'll pull that up. What you're going to need to do is to get it up and running on your computer. Get a spreadsheet up, Excel or whatever you use. I use OpenOffice. They're very similar, and I'll walk you through the steps to complete this activity and be able to use a spreadsheet to do the same kind of. Okay, for activity 1, we've got a spreadsheet. It asks us to go through this and create one and put in the information. So I got day X. Option 1 is my constant increase option. Option 2 is my percentage increase option. And I want to get my days in, so my day 0 goes first, and then day 1. I think I got enough where I'm going to grab the handle. You'll notice follow my arrow of my cursor. When it hits this highlight point, it changes. That means I can pull this down and get it to replicate what I put in. That's going to be useful here. So for option 1, we started off with $10, and for option 2, we started off with $10. Now for the first day, we'd like to create an equation that'll let us find out how much we get. So I put in equals, and it's going to be equal to the amount from the previous day. This is a now and next calculation. So it's going to be what's in the previous cell. That's B2. I'm going to add to B2 the amount of $50. And I get 60. That's what I thought I should have had. For option 2, again, I hit equals. I can now do my calculation. I'm going to have what's in cell C2. I'm going to multiply that, and with an equals sign I can begin to do a calculation. And in this case I'm going to take what's in the previous cell, C2. I'm going to multiply it times 1.5. This will be my next now calculation, and I get 15. That's what I got previously. I can test these. I'm going to replicate these two formulas. I'm just going to go down one spot, and I had 110 for the linear increase, constant increase, and 2250 for the percentage increase. Well, I can still grab the handle. I can populate all of these. I'm going to pull it down. I get my results, and I see that it was $710 at the end of 14 days, or $2,919 at the end of 14 days. So this is using a spreadsheet to create a next now formula. The other thing we can do with a spreadsheet is to put in a formula that would be able to do a calculation for any given x and doesn't require the previous result to get it. And that would mean for our linear expression L of x, which is equal to 10 plus 50x, and our exponential expression e of x equals 10 times 1.5, my caret symbol, raised to the x. So these are the expressions that I'm going to use to make this work, and I can pop those in right away. My x value is over here in column A. So I select the cell I want, I click equals, the formula I want is 10 plus 50 times what's in cell A2. And that's the x value for this particular row for day 0. That's my formula for the linear increase. My formula for the exponential increase is equal to 10 times 1.5 raised to the A2, and that should give me 10, they're all stay 0. When I increase it by 1, I should have the results I got before. Yeah, 60 and 15. I can replicate this. I grab the handle, I pull it down, and I see that I've got exactly the same results between the two columns. So you should be comfortable doing this kind of work. We're going to be doing it again here for the next activity. So we'll want a new page, get a new spreadsheet up and running, and let me go to the next problem. Activity 2 is this cougar or mountain lion population. They repopulated an area with 19 lions. There's two scenarios. One is constant increase, where things are limited, and the other is no limitation and a 6% annual increase. We want to do a spreadsheet to evaluate what happens with them. When would one option provide a larger population than the other? We'll get our spreadsheet back in here. I'm going to new spreadsheet. We'll get a different one up and running. Yeah, I know I could have just gone to a different sheet, but don't want to confuse myself. So the first thing we've got here is year. The next category is option 1. Option 1 is our constant increase option. Option 2 is our percentage increase option. And the year we start is 1993. Then we go annually, 1994. We could keep doing this till we get up to where we want to get to, or we want to stop, or we can replicate it, grab the handle. I'm going to look at 2015 because we're there. And let's see what we've got. For option 1, it was 19. Oops, I need an equal sign. Okay, equal to 19 plus just 19, right? Yeah, 19. And option 2 it was 19. And for our next now, it is the previous cell plus 2 gives us 21. And in option 2, it's our previous cell times 1.06. It was 6%. Right? Yeah, 6%. So the C2 times 6% tells us we got about 20. And we can go ahead and do our replication of both columns. Grab our handle, pull down, let go, and it didn't work. Why not? Oh, I selected both cells, that's why I only needed to select the one. It was confused because there's no formula in cells B2 and C2. So I just had to select B3, C3 and replicate. And now I can look at this and see that right around 2012 is when we're going to looks like we have about the same number of mountain lions, and it increases from there using the exponential option. So let's create a couple of explicit formulas to evaluate this. Our L of x, which is the linear and we need to figure out that's going to equal to 19 plus 2 times x. And our E of x, E is going to equal to 19 times 1.06 raised to the x. Okay. I just double clicked on the boundary to expand that. So now I got to figure out how to write this, because 1993 is not my x value. That's year 0. And 94 is year 2. So I might want to create another column to show my x values. I guess I could do that. Let's see what that would look like. So I'm going to go ahead and just call this x. This is going to be year 0. And, I don't want to have to count all these. That seems boring. So what I know is, well, this is year 1, but it's 1 year apart. So I know that 1994 minus 1993 is going to equal 1, but I want to replicate it. I don't want to have to put in a new value each time. So I'm going to put the cell, I'm going to subtract 1993 from it, because that'll give me the x for each one of these. And it gives me 1, so this next one should be 2, right? Okay. There we go. Now I got some x values created, and I can use those in these expressions. So it's equals 19 plus 2 times what's in cell F2, and that should give me 19. This next one should give me 21. Yeah, it does. Cool, 21. Okay, so E of x, this is equal to 19 times 1.06 raised to the x power, and x is what I find in F2, raised to the F2, and that should give me 19, and it does. And this should give me 20.14. Good, cool. Okay, so now I got my formulas in place. I'm going to go ahead and I'm going to replicate them. And I see that indeed the replication works. I have my results. Now what's cool about Excel is that I can plot these results on and graph them. And so I'm going to go ahead and take the option 1, option 2, and year categories. I'm going to go up here to my graphing icon. You're going to have a chart or graphing icon somewhere on your spreadsheet. Click it. And it's going to give you some choices for your chart wizard. What we want is a scatter plot. So I'm going to check scatter plot. I'm going to click finish. And now I see that I've got my years listed as my x-axis. My y-axis are the number of cougars. And I can see that I have option 1, option 2, and I can see that somewhere around 2012 or so they begin to equal, and then beyond that it looks like 2013 there are more in the exponential option than the linear option. So that's it for this lesson in terms of examples. I got one more thing to review with you before I let you go. The spreadsheets are right here. You can, if you need help with it, come and see me. Glad to help out. And good luck with things. Hang on, let me get to the other one last page here. Here we go. Constant increase and exponential growth. Just wanted to compare them. You can see the linear growth is just that. It's an L of x equals mx plus b, and m is greater than 0 gives me growth. Exponential growth, is the growth factor raised to the x power, where g is greater than 1. Now here's a table that breaks it down even further. When m is greater than 0, it means an increase. When g is greater than 1, it means growth. When m is less than 0, it's a decrease. And when g is between 0 and 1, when it's a fraction, it means decay. Our constant for m equals 0 is a constant function. For g, when it equals 1, it's a constant function, because it doesn't matter what x is, 1 times 1 is always going to be 1. Alright, that's it for this lesson. Good luck. I'll see you in class.